Hello guys, welcome again. So today we are going to speak about differential equations. So just by far we are going to start making a introductory note on differential equations. So what is differential equation, what we mean by differential, what we mean by equation, because we know that differential, it is nothing more or less than the rate of change of a quantity with respect to another one. So whenever we have a change of a quantity with respect to other one, we can just put this change in this form, like d of y with respect to dx. So this is one of the way to write the differentiation of y, that is dependent variable, with respect to x, that is our independent variable. So dy by dx express the rate of change of y quantity with respect to x. So here we are going to start speaking about differential equations. So what is differential equation? First, differential is this. Now, what is equation? Equation, it is nothing more or less than, let us say that this is, we know that any equation is an equality. It must be an equality like this. Here you can see it is an equality. Okay, equality. There we have a side, left side member, or left side part, and right side part. So this can be called a equation because it is an equality. Okay, it's an equality, and we have some, how can I say, we have here some unknowns that must be found. Okay, this unknown. So in a nutshell, an equation, it is one equality, an equality at which we can have at least one unknown to be found. Okay, so to be an equation, there must have one unknown to be found. But for a differential equation, the unknown to be found, it is the derivative. Actually, that's why it is called differential equation. So the term that is differentiated will be our unknown, and this will be the point that we are going to find. Suppose we have this expression over here. Okay, this can be called as a differential equation. Why? Because here we have to find what is dy by dx. Here it is 3 times. Okay, we have to find, this is a, how can I say this one, dy by dx, and this derivative, it is repeated 3 times. Okay, so here we have to find the first term of y, the second term of y, and the third term of the y. Okay, of y, as long as we can see here. So now, by understanding it better, we have to look on some things that will make us feel a little bit more comfortable on this. Any differential equation can be written like this. As you can see, it is dy by dx, then x, dy dx, then y. Okay, as you can see here we have dy dx, x, and y. So you can also write the differential equation like this. Okay, f of x, y, and dyx. Okay, where y will be our dependent variable and x will be our independent variable. Nice. Now the next thing that we have to understand better, oh good, before start calculating, is which are the types of differential equation that we know. Okay, the differential equation. Okay, differential equation is divided in two types of in two parts. Okay, we have ordinary differential equation, okay, and we have partial differential equation. So it is explicit because whenever we have, when do we have ordinary differential equation? Ordinary differential equation we have when the differential equation, or when we have only how can I say, total derivative. okay, when we have total differentiation, like we have only one, okay, only one variable to be differentiated, then we call ordinary differential equation. Okay, and this ordinary differential equation is divided in two parts. Okay, first order and first degree differential equation, and high order differential equation. And partial differential equation, okay, as the name it said itself, okay, whenever we have partial differential, it's like a partial differentiation of anything, like if it is not total differentiation, so we have partial differentiation. Partial differentiation stands for more than one variable, or more than one dependent variable is in case. Suppose we have f of x, y, z, f of x, y, and things like that. So we have to find what is the differentiation equation of this differential in case. Yeah, we have just to go on this. Okay, so whenever, just in a nutshell, ordinary differential equation, it is applied only when we have total differential, okay, total derivatives. And partial differential equation is applied when we have partial derivatives, okay, in which we can find more than one variable to be differentiated. Nice. And then we have here first order differential equation and high order differential equation. So for these topics, we will be based on this first order differential equation and high order differential equation. Just for, as per our syllabus, we will just be focused on these two parts. Okay, this one can be for next time. Okay, so let us understand now what is actually order of a differentiation. Okay, so order of differential equation, it is nothing more or less, as you can see here, it is what? It is the order of the highest derivatives appearing in the equation. So whenever we see a differential equation like this, suppose here we have this one, so suppose they're asking for finding order of the differential equation. To find the order of the differential equation, the first thing you have to do is, okay, look for the highest, okay, the order of the highest derivative in this equation. Okay, so here we have a differentiation, okay, dy dx, and here we have a differentiation too, but the highest, this dy square dx square, and this dy and dx, which is having the highest order, actually is this one. So the highest order, okay, of this derivative, it will express the order of the equation itself. So it means that here, suppose the order will be, for this equation, the order will be 2, okay? And subsequently, following this, if you see, now what is degree? Degree, it is the power of the highest derivative appearing in the equation. So following the same knowledge, if we know that this is the order of the integration 2, okay, because this is twice derivative, here we derived 2 times, okay, and here we derive only 1 time. So this is the highest derivative appearing in this equation. So for this highest derivative appearing in this equation, okay, here we will take also the power of this highest derivative in this equation will be the degree of this equation also. It means that from the term that you find the order of the equation, yeah, you will pick up the power of this the power of the term that is holding the order of this equation. The power will be our degree of this equation too. So it means that it will be 3. Okay, So this is very important to know. Okay, so it means also even from here, okay, you can just see, just look, what is the highest derivative in this? It is surely this. Okay, so it means that the order of this equation is 3. Okay, now what will be the degree of this equation? So sorry, okay, what's the degree of this equation? To find the degree of this equation here, neither the degree of an equation, of a differential equation, or order of a differential equation has to be in how can I say, has to be in fraction. Okay, so here you have just to do some basic calculation and find here, in order to make it just a integer number. Okay, just like this, suppose it is d cubed y upon dx cube, it is 1/2. So this is an equation, this can go for to them, so it will be 3 positive 3xy cube, then here you have dy dx, and here it will be 3. Now to this one, to become an integer number, I have to multiply here. Okay, I have to add here in the exponent, in the exponent 2, and here also in the exponent 2. So what will it be? It will be dy cube upon dx cube, and it will be 3xy cube. Okay, 3xy cube, and it's all square. Okay, and here it will be dy dx to the power 6. Okay, as you can see, now I can say, so in this equation, what is the highest derivative present in this equation? The highest derivative present in this equation is this one. So it means here I can say the order is 3, but the degree of this equation is only 1. Okay, yeah, just like this. Okay, so for this one we can write just here, order is 3 and the degree is 1. Okay, and also similar way you can find this guy for this okay, dy square, and this one is okay. So as you can see here, the order will be 2, okay, and the degree will be 1, and so on. Okay, so now that we know, let us start solving, or let us just have a quick look on the first order and first degree ordinary equations. Okay, see, first order and first degree ordinary equations. Okay, this is nothing but, this is an expression like this. Okay, so you can see, just have a reading on this. It's an equality, okay, containing the first order and first degree derivatives of y, that is dependent variable, and known function of x, that is independent variable. Okay, in a nutshell, first order and first degree ordinary equation, it is, okay, first, if it is ordinary equation, it means that it has only one dependent variable and one independent variable too. Okay, so it is first order. What does it mean? It means that we have only one derivative. Okay, so it is not repeated. So y is once differentiated with respect to x, and also this once derivative part of y with respect to x is not repeated more than one time. It is only repeated one time also. So this is what we mean by first order and first degree differential equation just by looking at this, okay? And this can be written in this form, okay? f of xy, okay, dy dx. As you can see, this dy dx, how many derivatives do we have here? Only one derivative. It means that the order of this derivative is only one. And what is the degree of this equation? The degree of this equation, just by seeing here, it will be 1 also. Why? Because it is only repeated one time, okay? One time. And it is also one time derivative, okay? So one time derivative and one time derivative and one time repeated, okay? So this is first order and first degree ordinary equations. So this can be written in this way, or it can be written in this way: dy upon dx equal to f of xy. Or it can also be written in this way, okay, in a linear way. So yeah. And this kind of equation, this first degree and first order and first degree equations, okay, surely have solution, okay, and have a different method to be solved, okay. Yeah. And first let us understand what is a solution. How do we call solution, or what is the solution for first degree and first order differential equation? So solution for first degree and first order differential equation, it is nothing but the relation between the dependent variable and independent variable, okay? The relation between y, that is known as dependent variable, and x, that is independent variable, with, okay, the relation between them. This is the solution of this ordinary equation. But it must not contain the derivative expression inside them, okay? It must not contain, just like this. Suppose we have this is solution. This is what we mean by solution. But ordinary derivative differential equation, first let me call this one, this is for first order, okay, first order, and also first order and first degree ordinary differential equation. They usually they have not only one. It is in general every ordinary differential equation or partial ordinary differential equation, they have three different solutions, okay? Yeah. And even in this first order and first degree, we will find also three different solutions sometimes. Okay, so it is in general. In general, all the ordinary differential equation or partial differential equation, they have three solutions, three distinct solutions. The first is the general solution. The general solution, it is the solution that can contain all possible solution of a differential equation, okay? But sometimes it do not contain all the solution, okay? Sometimes. Particular solution, it is obtained from the differential solution, okay, from the general solution. But this particular solution, it is when we applied a particular value of a arbitrary constant in this general solution. Suppose we have a solution like this: y is equal to x, a solution, okay, x plus c, because solution is the relation between dependent and independent variable. Y is equal to x plus c. This is the solution for one differential equation. Now, what do we have to find? Suppose the differential equation is this: dy upon dx is equal to 1. okay, and we found this solution. This is solution SG, okay, general solution like this. Suppose it's GS, y equal to, okay, y equal to x plus c. This is the general solution. Suppose for this one, for this equation first here, this one. So what do we have to say? We have to say that the general solution is y equal to x plus c, right? Right. This is the general solution. But particular solution will be, what will be the value of this c? Okay, to find particular solution, we have to find a particular, in a particular point, what will be this c? Okay, so this we will call particular solution. It is obtained for giving value of giving a particular value to the general solution. Okay, suppose for c equal to 2, so we will have here a particular solution, y is equal to x plus 2, okay, and so on and on. And sometimes we have also some single solutions, okay, single solution. Suppose we have an expression like this, dy square sorry, dy square here, this is differential second order y dy square, and here the x square plus dy upon dx, and here we have plus y, okay, it is equal to 0. Suppose we have an expression like this, okay, so here even before we start solving this, we can directly see, okay, not calculating, by just by inspection we can understand that y equal to 0 will be a solution for this equation, okay, will be a solution for this equation. And this y equal to 0, generally, to be considered as a single solution, it must not be contained, it must not be inside the general solution. So single solution, it is a solution that you cannot find neither, or you cannot find in the general solution, okay, by finding the general solution, or in a particular, by finding a particular solution. Okay, this is a solution that you can find by inspection, or sometimes they just, it is already you can just without applying any method, just by inspection, you can directly see and not find, okay, now this solution can also solve, and this can be solved, and so on and on. Okay, and sometimes it is just given, you just find them directly for this. So this is what we call single solution. So single solution, again, it is not found by, it is not a, how can I say, it's not in the interval of solution presented by general solution, and neither is it in the solution found in the particular solution too. This is a single solution, this is singular, okay? So like some people will call this a singular, not single solution. Then it's okay, singular solution or single solution, it doesn't, it's not that much a problem. Okay, nice. Now what we are going to start, okay, during this time, it is to find, or it is we are going to start solving different method, different ways to solve first order, it's like first order and first degree ordinary equation. So sorry, here that was to be written something like first order and first ordinary and first degree ordinary equation method to be solved, or to solve. Okay, so we will start, and to solve equations like in the first order and first with the first order and first degree equations like this, dy upon dx plus, suppose upon dx plus x, y equal to c or equal to 0, equations like this, we have many ways to solve these kind of equations. Okay, so the first thing is just to understand the nature of this equation. Okay, the nature of this equation, then we can solve by any method that we can find here. First, we have to understand what is the nature of this differential equation. Now, from there, we can go directly and solve and apply any of these method. So we are going to start from variable separable method. Okay, then we are going to go through this homogeneous ordinary differential equation and non-homogeneous ordinary differential equation. But this is homogeneous and non-homogeneous ordinary differential equation for first degree and first order equations. Okay, like this. Okay, yeah. Sometimes the function itself is how can I say homogeneous. Sometimes are not homogeneous, but is this function of first degree and first order? Yeah, it is. Then we have a different way to approach and to solve this problem. But if it is from another one, or if it is a different one, we have another different method. But all in all, it will be something not that much difficult to you to understand. And there is another method. It is to check if we have exact differential equations and non-differential and non-exact differential equation reducible to exact differentiable equation. So yeah, these are the ways that we are going to go through just to find out, to know how to solve these first ordinary equations. Okay, first degree, first order ordinary equation. Okay, and here we have also in the fourth method, it is like linear. Whenever we have a linear differential equation, okay, linear differential equation, that's also called like Leibniz equations. Okay, and non-linear differential equation that can be reducible to a linear form. This we call Bernoulli's equation. Okay, yeah, this is what we are going through during this time. Okay, so I will start with this variable separable method, then homogeneous and non-homogeneous odd method for solution. Then we are going to start for exact differential equations and non-exact differential equation that can be reducible to exact form. Then we will jump to linear differential equation, that is Leibniz equations, and non-linear differential equation that can be reducible to a linear differential equations. So hope you can stay there. And yeah, just to finish this video, let me just solve this one. Okay, for this one we can apply the first method. Okay, because for the first method, as long as you can have dy and dx, okay, as long as dy dx, the condition to apply this separable method, as long as is that you have to have dy upon dx equal to f1, that is a function of x, time, okay, fy must be a function of this one. So this is the condition. It means that you have to decide to apply separable method, you have to find out that this equation can be written in this form: dy dx is equal to f of x times f of y. Okay, this can be, yes, this can be written in this form. So you just take this one, this will be dy upon dx is equal to minus x and y. So as long as you can separate f of x in a function of x and y in a function of y, so this can be solved by separable method. So you will just come here directly. So dy upon dx is equal to xy negative. So this x come here and this y go there. Because in this separable method, what you have to do is just to put dx with x and dy with y, just like this. And dy here will be upon y, and here you get minus x dx. Okay, Then you have just to solve, apply integration here, okay? So what you are going to have, you are going to have ln of y is equal to x squared upon 2 plus c, okay? X squared upon 2 plus c. So this is what we call general solution for this differential equation, okay? Just by starting, see you next time. We are going to start for variable separable method, okay? Bye.